So the next problem that we're going to do is problem A from the permutation group's adventure sheet. So this is warming up with writing elements of Sn for various n. So the first problem is to write the permutation in cycle notation denoted 135 to 7 as an element of S7 in stack notation. So what we want to do is observe where each of the elements go. So what this stack notation means, 2, 3, 4, 5, oops, 6, 7, is it says 1 goes to whatever's here, 2 goes to here, 3 goes to here, 4 goes to here, 5 goes to here, 6 goes to here, 7 goes to here. So where does 1 go?
Well, the cycle says that 1 goes to 3, is what the cycle notation means.
Great. And then where does 2 go?
7, I guess.
Okay. And 3, based on the cycle notation says that 3 goes to 5. What about 4? I don't see it. Where does it go?
Yeah, I don't see it either. Let's come back to that one.
Okay.
I mean, it's a permutation, so maybe we can just do process of elimination.
Okay, great.
Okay, so 5, I guess, is the next one. Does it go to 1 or does it go to 2?
That's a great question. Well, what does this closing parentheses mean? This closing parentheses in our cycle notation tells us that this is a cycle. So it tells us that when a parenthesis closes, we cycle back to the beginning.
Okay.
So that means that 5 goes to 1.
1, right. Okay, I'm with you.
What about 6?
That also doesn't show up.
Okay.
But 7 goes to 2, because that's a cycle.
Great. So then we have to figure out what happens if we don't see an element.
Yeah.
Well, if it's not written, what this cycle notation tells us is it tells us how to map any element to any other element.
Right.
But if something doesn't show up, that means that it's not changed by the cycle.
Right. Yeah. Yeah, I guess right. So this is either 4 or 6, and the same thing here. And if they switch, then there would actually be a 4, 6 here.
Indeed. I agree.
Okay, so that's not happening.
So we should put 4 here and 6 here.
Okay.
Great.
Cool.
Okay, so here we went from stack notation to cycle notation to stack notation, but then our next problem is to write the permutation given in stack notation in cycle notation. And by the way, we're doing problems from your adventure sheet, so you have access to these problems if they're illegible to you. Okay, so we want to write this permutation in cycle notation.
I'll get us started.
Okay, great. I like that start. Okay, so when we're writing in cycle notation, we're trying to identify where each element goes. So what this stack notation tells us is it tells us that 1 goes to 3.
Yep.
And if I wanted to denote that in cycle notation, I would write a 3 after a 1.
Right. Okay.
So now it's your turn, Eric.
Okay, so like up here, the next number said that 3 went to 5, so let's see where 3 goes to keep going with the cycle. Okay, so 1 went to 3. Where does 3 go? 3 goes to 1. So this is making me think of how 2 went to 7 and 7 went to 2. So I think we're just going to close that.
Why did you look at 3 rather than 2 next?
Well, because I want to know where 3 goes. I'm not worried about 2 yet.
But why?
Well, because like the way the cycles work is it tells you like 1 goes to 3, 3 goes to 5, and then 5 goes to 1. And so I wanted to go 1 goes to 3, and then 3 goes where?
Okay, and we see here that 3 goes to 1.
Right.
So you close the parentheses, you close the cycle to tell us to go back to the beginning.
That's right.
Okay, great. So then what do we do next?
Open parenthesis. And now.
Okay. Now what number do we look at?
The next one we don't know what has happened to.
Okay.
What happens with it?
Okay, so 4?
Sure. Let's do 4.
Okay,
Okay.
so 4 goes to 2 is what this tells us.
Uh-huh.
And then 2 goes to 6. And 6 goes to 7. Okay. And 7 goes to 5. And 5 goes to 4.
Uh-huh.
Oh, and that's where we started.
Right. Okay.
Great.
So one thing that's confusing me now is I was thinking that the next number was 2, because we hit 1 and 3, but we don't know what happened with 2.
Yeah.
And so I thought we were going to do 2 here. Maybe I'll do this in green. I thought we were going to do 2,
Why?
because that was the next number that we didn't do yet. We did 1.
Okay.
We haven't done 2, so I was going to start with 2.
Okay.
And then that goes to 6.
And 6 goes to 7. And 7 goes to 5. And 5 goes to 4. And 4 goes to 2. So we start over. Okay. So these are 2 different answers, but are they, like, is there a way of... But, okay, so they're 2 different answers, but they came from the same stack.
Right.
Which means they should have come from the same permutation. So do
Right.
these 2 things mean the same thing? They must, right?
Yeah.
Because we got them from the same permutation.
Yeah. Let's see. Well, hold on. Here's a 2, and then 6. Yeah, so it's like all the elements are the same, they're just diagonal.
And then this close parentheses tells me to go back to the beginning, which is sort of like moving the 4 from the beginning to the end.
Yeah.
So that maybe they're called cycles because they sort of cycle, they form like a circle.
Yeah.
Ooh, I could draw this.
Do it.
As a circle.
Sweet.
Right? So I have like 2 goes to 6, goes to 7, goes to 5, goes to 4,
Nice.
goes to 2. And so they're sort of circling or cycling around.
Yeah.
And this notation is conveying that, and I can start anywhere I want, but it's always going to convey the same information.
Uh-huh.
Cool. Cool.
Yeah, do we want to do the next one?
Yeah, let's do the next one.
Okay.
So the next one is a product. So we want to take the product of sigma, which in cycle notation is 1, 2, 3 times 4, 6, and tau, which in cycle notation is 2, 3, 4, 5, 6. And we're writing these as elements of S7, and we want to compute their product sigma tau. So I have a few questions right now. My first question is, I don't see 7 appearing. Is that okay? What does that mean? But I guess that goes back to this first problem. The weird thing is it's like the last number, so why isn't this just an element of S6? Whereas here there were like middle numbers.
Yeah.
But I think that this is okay.
Yeah.
There's just
I guess if you're doing a permutation of 6 things, then you can also permute any bigger number by just not doing anything.
Yeah, not leaving the last one. But then we're trying to compute this product sigma tau.
Yeah.
And then the question is, in what order does that mean that we multiply them? Okay, so if we write out sigma tau, one thing that we can do is we can just literally write out sigma tau equals 1, 2, 3, 4, 6, 2, 3, 4, 5, 6.
Right.
But then the question is, do we go from right to left or do we go from left to right?
So on the first worksheet for groups, we said something about like we do it like function composition.
Right.
And these are functions, so I think we want to go this way.
Okay. Oh, why didn't we talk about this earlier? We just did 2 problems. Why is this only coming up now? Did we do the other problems wrong? How did we do them in the other problems? Oh, well, here's a feature of the previous problems, is in problem 1 and 2, we had cycles that didn't share any numbers.
Right.
And so it sort of doesn't matter what 2, 7 does to 5, or what 1, 3, 5 does to 2. What matters is what this whole thing does to 5, but only this half of it does something to 5. So I think I read in the book that this is what's called disjoint.
Yeah.
They don't contain any of the same numbers.
Yeah.
And when two permutations are disjoint, it doesn't matter what order we do them.
Right.
Okay, but here they're not disjoint, so the order actually matters.
Right.
Okay, so I think, Eric, you reminded me that we go from right to left.
Yeah.
Okay, cool. So if we want to write this product out, oh, and we're asked to write this as a product of disjoint cycles. And disjoint is, again, what we just acknowledged here, that the cycles shouldn't contain any of the same numbers.
Right. But it seemed like that kind of happened automatically when we were doing this.
It did.
So probably let's just
see what happens.
Let's just see what happens, and then if they end up not disjoint, we can deal with that. But let's just see what happens. So, should we start by seeing what happens to 1?
I like to start with 1.
Okay. Okay. So 1's going through.
Nothing.
Nothing.
2. It goes to 2.
Okay.
Okay. So where does 2 go? Well, here 2 goes to 3.
Okay. So now it's 3, and 3 goes to 1, I guess.
Wait. What did you just do?
Well, I was thinking that. Okay, so I was thinking of this as a function composition.
Okay.
So here, 2 went to 3, and so now I'm plugging 3 into this other permutation, sigma.
Oh,
I want
okay.
to know what sigma of 3 is.
Gotcha. Okay, and so if I apply 4, 6 to 3 as a function, nothing happens.
Nothing happens.
So then I look at what 1, 2, 3 does to 3.
Right.
And I know from what we talked through before that this means that 3 goes to 1. So that meant that 2 went to 1?
I guess.
Okay.
It's weird that 3 doesn't show up there. But yeah, I guess the 2 goes to 1.
Okay, so I close the parentheses and I open a new one. Okay, so we look at where 3 goes. So here, 3 goes to 4.
Mm-hmm.
And then plugging 4 into this new function,
Yeah.
I see that 4 goes to 6. Oh, I should have written 3 there so I don't forget.
Mm-hmm.
I see that 4 goes to 6, and then 6 is unchanged by 1, 2, 3.
Yeah.
So 3 went to 6.
6. Yeah, I guess so. Okay.
Okay, and then I want to see where 6 goes.
Yes.
Oh, okay, so 6 goes to 2.
Yeah.
And then 2 is unchanged, and then 2 goes to 3.
Yeah.
Oh, wow, weird.
Okay.
Okay, what next?
4. Okay, so 4 goes to 5. Now we're plugging 5 into sigma. Okay, and 5 doesn't show up,
Yeah,
so it
there's
goes
no 5.
nowhere.
Okay, cool. And then I bet I know what happens.
Do you think it's going to all be these 2 cycles?
It must be, because I think 7 doesn't do anything, and so...
Oh.
Well, why don't we check?
Okay, that's a good point, though, that 7 doesn't show up here, so we don't expect 7 to move based on what...
Yeah.
Okay, all right, I'm with you.
Okay, so here 5 goes to 6,
Yep.
and 6 goes to 4.
6 goes to 4.
So that's what's happening. And again, like 6 is here, so it doesn't show up here.
Yeah.
Sometimes I get mixed up, because like 5 went to 6, but it didn't stay at 6.
Right. Yeah.
Okay, yeah, so 5 went to 6, but I wasn't done when it went to 6. I wasn't
That's right.
done until it went to 4.
That's right, we have to plug it in over here.
Okay, great.
Okay.
Great.